So today we're going to talk about the concentration of solutions, and we're going to focus on three different parts of it. The first part that we're going to focus on is being able to calculate the quantities needed if you want to make a very specific solution. So to do so, we got to first get into what is concentration. So concentration, when we talk about a solution, essentially tells you how much solute, the substance that's going to dissolve, is dissolved in a very specific quantity of solvent. So it kind of tells you like the strength of your solution. So you got two types. You have a solution that's either dilute or concentrated. A dilute solution is one that has a very small amount of solute, while a concentrated solution is one that contains a large amount. So for a solution in which there's a lot less solute in there compared to solvent, we consider it to be dilute. This is the equivalent of saying that something's like watered down because there's too much water and not enough of whatever else is supposed to be in there. While a concentrated one is where there's a lot of solvent, much more than a dilute solution. So if you take a look at these two diagrams, you can see that the concentrated solution has a lot more of those solute particles in there compared to the dilute ones. Now, when you talk about the concentration, basically talking about like the strength of the solution. So we can actually give that a quantitative value to it. So what we're going to discuss now is called molarity. Molarity represents the number of moles of solute dissolved in liters of solution. Here we're actually given a fixed quantitative quantity to each of the different components of the solution. Basically going to tell you how much of the solute is dissolved in a specific volume of solvent. So we have molarity given by the capital M is equal to moles of solute divided by liters of solution. So with these two, we can now basically give our solutions an actual like value. This is going to tell you how strong or how weak your solution is compared to how much you want it to make it. So let's take a look at a practice question here. So IVs, the one that are like used in the hospital that maybe you're familiar with, those are basically like salt water. Now the saline solution in an IV is going to have the salt dissolved in a very specific amount of water. So in this solution, we want to know what the molarity of the solution is going to be if zero point 0.9 grams of sodium chloride, salt, are going to be dissolved in 100 milliliters of solution. Okay, so we're going to take 0.9 grams of salt, dissolve it in 100 milliliters of water, and to try to figure out what the strength of it is or what the molarity is. So given that the molarity, M, is equal to moles of solute divided by liters of solution, we'll need two things. We will need the moles of the solute and we will need the liters of the solution. Okay, so our solute here, because of the fact that it's salt, sodium chloride, being dissolved, that's going to be our solute. So we got to take our 0.9 grams of sodium chloride and convert that into moles. So we're going to essentially multiply by 1 mole over the molar mass, or just divide by the molar mass of salt. That gets you 0.015 moles of salt. So we have our moles of solute. Next, we just need liters of solution. Well, if we have 100 milliliters, that is just equivalent to 0.1 liters. So our molarity here is going to be 0.015 moles of salt divided by 0.1 liters of solution, and our molarity is going to be 0.15, capital M here, and we pronounce that as molar. Molar is just moles over volume. Okay, so the strength of our saline solution is 0.15 molar. Okay, so this kind of tells me just how strong or how salty I made this thing is, basically. So let's look at another portion of concentration of solutions called dilutions. So we want to learn how to make a diluted solution, or basically how to dilute one. So when we talk about diluting something, we're basically talking about reducing the number of moles per unit volume. What that means is we're going to lower the mole to volume ratio. So the way to do that is we're going to lower the concentration by increasing the volume of the solvent. So diluting something does not change the moles of the solute in there. Once you have a specific quantity of moles of solute dissolved, you can't really change that. Well, you can't really decrease it, you can only add to it. But if you increase the amount of solvent and increase the overall volume of solution, you can effectively lower the concentration. Think of dilution as being able to water down something and calculating how much water you have to add to it. So, just going based off of what we know here, we can form what's called the dilution equation. That dilution equation relates two different solutions. You have your original and you have your diluted. So we have it as M1V1 equals M2V2. Basically, the concentration times the volume of the first solution is going to equal to the concentration times the volume of the second solution. The way that we know this is because of the fact that we have two solutions. We know that the number of moles are going to be the same. So we know that the moles of solution 1 should equal the moles of solution 2. Well, given that molarity is equal to mole over volume, just kind of rearranging this, you get that MV equals to mole. So if we're just setting this equal to each other, you have basically the concentration and the volume of two different solutions should be the same because they have the same number of moles of solute. So that's basically how this equation was derived. And this will just tell you, if I want to make a specific diluted solution, how much of the original am I going to need, or how much water do I need to add, or how strong will I make it. So you can basically figure out a lot of things here. So now let's take a look at an example of diluting a solution. So we want to know how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted to prepare 100 milliliters of 0.4 molar magnesium sulfate. So there's a lot of values here. The most difficult part is just interpreting what the numbers represent and where they're going to go. So keep in mind that we have M1V1 equals M2V2. Molarity times volume of the first solution equals molarity times volume of the second solution. Now we want to know how many milliliters, so a volume of aqueous 2 molar solution, has to be diluted with water to prepare 100 milliliters of 0.4 molar. So immediately we can see that the 100 milliliters of 0.4 molar is going to be our diluted solution because we're going to add water to it. The concentration is lower, so that means this has been the solution that's diluted already. So we have our M2 and our V2. Okay, so we know that the M2 is going to be 0.4 molar because that's going to be the concentration of our diluted solution, and we're going to have 100 milliliters of this solution. Now we want to know how many milliliters of the original 2 molar solution is. So we're going to be solving for V1 here. Since we know that the original is 2 molar, just plug that in. We have V1. Now we just have to go ahead and solve for the original volume. Okay, so just doing a little bit out of algebra here, you get that V1 is going to equal to 20 milliliters. So what this tells me is that if I have a 2 molar solution, I will need 20 milliliters of that solution. I must dilute it up to 100 milliliters, and the concentration of that will be 0.4 molar. So this tells me what volume of the original solution I'm going to need to measure out if I want to dilute it to a very specific quantity and a very specific concentration. So here you basically figure out how much water I'm going to need to add in order to weaken my solution to whatever my purposes are going to be. Now lastly, we're just going to talk about percent solutions. This is essentially just another way to represent concentration, but we're going to be using percentages rather than the actual like molar and molarity stuff. So we have two types. We have percent by volume. This is useful when both the solute and the solvent are in the liquid state, and we could just represent the concentration as a percentage of the solute in solution. So the percent by volume is given by the volume of the solute divided by the volume of the solution times 100 to make a percentage. It's going to tell you, okay, if I have this many, milliliters, liters of the solute, and I have this much, this volume of the solution, and what percentage does the solute compose out of my entire solution? Pretty simple. And on the other hand, we have percent by mass. This is more useful when you have a solid involved. Typically, the solute is going to be the solid here. Just another way to represent concentration, but rather than talking about molarity and moles, we're just going to use percentages. So you can represent this one as just the grams of solute dissolved in whatever the mass of the solution is going to be. You actually see this a lot with food labels. For example, juice. You ever see like that 5% juice on some like cartridges? That just tells you that 5% of that entire thing is the juice powder or whatever the concentrate is that they use to make it. So similar to the percent by volume, this is going to tell you the percent by mass is equal to mass of the solute divided by mass of the solution times 100. So it's just two other ways to represent concentration without having to deal with moles or molarity. You can actually use percentages to tell you. So now let's take a look at an example here. We want to know the percent by volume of ethanol in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 milliliters with water. So we want to know what percentage ethanol is going to make of the solution with water. Okay, so since we know the percent by volume, which we could represent as percent VV, well, sorry, V over V, this is going to equal to the volume of the solute divided by the volume of the solution times 100 because we want to make that a percentage. All right, so the key thing here is just kind of interpreting the numbers the right way. So we have 85 grams of ethanol diluted to a volume of 250 milliliters of water. So our 85 milliliters of ethanol, we know that ethanol is going to be our solute. So we're going to have 85 milliliters of that. And I'm just going to go ahead and label the ethanol formula here so we know what we're talking about. And the key here is it says to a volume. To a volume means the final volume of the solution is going to be 250 milliliters. Now, if it said with a volume of 250 milliliters, then we know that we're adding on to the original of ethanol. But because we're saying to a volume, that means the final is going to be 250 milliliters. So we want to look for context clues like that to basically tell you exactly what the final volume is going to be. It's very subtle sometimes, so you want to look for things like to or with or added to kind of give you an idea of what the final volume is going to be. Here, because we know it's going to be to a volume of 250 milliliters, that tells me that's going to be the final volume. So we just have 85 divided by 250 milliliters times 100. And that's going to give us roughly 34%. So if I have 85 milliliters of ethanol, I'm going to go ahead and dilute that to 250 milliliters. My solution is going to be 34% ethanol. Okay. So you've seen other examples of this, like with like vinegar. A lot of vinegar at home is around like 5%. So that tells me that the vinegar, acetic acid, 5% of what we're actually using for like salads and stuff, 5% of that is actually acid. The other 95% is going to be water. So that's how percent by volume kind of gives you more information.